Hi guys, I'm Devansh Mangal from DesignVerse and I welcome you all to this amazing lecture series on design. आवाज थोड़ी अलग थी I know. ठीक है. So this lecture will focus mainly on machine elements and what are the design procedures. Okay, not procedures. What are the design methods? Okay. So before going on to the what is machine elements, what are machine elements, we'll move on to what actually is machine. So for questioning and answering that, this professor asked a very good question: what is machine? And a movie known as Three Idiots. I guess everyone might know that movie. Okay, okay. So in that very movie, this very person, Amir Khan, he answered that machine is anything which reduces human efforts. Okay, a zip in a pants, that's also a machine. Like you can एक सेकंड में up, एक सेकंड में down, एक सेकंड में up, एक सेकंड में down, like that. Okay, so he mentioned a machine like that. Okay, so probably he was right. Yeah, not probably, he was actually right. Machine is anything which actually reduces human efforts, and a machine consists of machine elements, and the parts of machine are known as machine elements. Okay, so a machine elements, what actually is machine elements and what is the technical definition for that? So any part of a machine which has motion with respect to other part are known as machine elements. Okay, so as you all know, like I'm very fond of automobile, so I took an example for a wheel assembly. Okay, okay, I guess the spelling's okay. So the wheel assembly comprises of different components. Okay, so these are different components are actually the machine elements. The wheel assembly as a whole is a machine, and these components are machine elements. And well, basically, before moving on to this, like this lecture might say that machine elements, but I would like to say that I would like to take this opportunity and like pause it for a minute and like say to you that this applies equally for like the product elements also. Okay, maybe civil engineering or any kind of other engineering also. This is not limited just for the mechanical engineer. Some people are having doubt in that. So just to clear that, this lecture series is not restricted to any branch of engineering. Okay, this lecture series is for everyone. Okay, so that's there. Okay, so okay, let's move back to it. So as I said, like this is what, this is wheel assembly, right? Okay, this is wheel assembly, and these are different components of wheel assembly. Wheel assembly as a whole, we can call it as a machine. Well, perhaps car is a machine, and car has the machine component name as wheel assembly, and wheel assembly further has components further divided, and those are machine elements. Okay, so maybe we can say wheel assembly is a machine element for a car, and this different components are machine elements for wheel assembly. This all can be related. Okay, so here we can see there's a bearing. Okay, and there's a spindle, and maybe like there's a hub also. Okay, and in between all them there is a what we call as a stub rod. Okay, a stub rod is there, or some people might call it a spindle. Okay, a spindle is what? It's just a part like the which comes out from the vehicle and extend, and over which the wheel hub is mounted, such that the wheel hub rotates while the stub remains stationary. Okay, so that's there. So how is it possible? It happens with with help of a bearing. Okay, so bearing is also a machine element. Okay, so let's discuss the machine elements in detail. Okay, so we know by definition that machine elements are just part of a machine which have a relative motion with respect to other part. Okay, so here we took an example of bearing, right? So we can also see like a bearing has the different components in itself. Balls are there, okay, and inner race is there, outer race is there, right? Shoulders are there, like separator is there, and all those things. So a machine element can comprise of different parts, okay, in it. So that's also very much possible. We must not restrict ourselves to this, like okay, this particular might have only this much things or not. Okay, everything is possible then. Okay, also this machine element has different parts of its own. Okay, so that's also there. Now let's move on to the types of the machine, like like machine elements. The machine elements also has type. Okay, so how did we classify that? One include general purpose, another one is special purpose machine elements. As the name suggests, general purpose machine elements are those which are used in larger application, while the special purpose elements are those which are used in specific per application. Okay, let's take some example for more clarity. So larger application general are the some are places where, like like you can just use them. Okay, if nothing is happening, like you can just use them. Okay, for example, shaft, bearing, gears, couplings. You can find these components almost like most of the machines which you see in day-to-day life. Okay, while the specific applications, for example, piston, you can only find a piston in, like, let's say a car, or let's say a compressor. Okay, but like the piston also has, like the bearing is also present here. So that makes the bearing as general purpose element. You cannot find a piston in your fan, right? But you can find a bearing in the fan, right? So bearing makes the bearing is like it makes it general purpose, and the piston is a special purpose element. Okay, let's not like dive into it further. I guess like that's very much clear to you guys. Okay, cool. So let's go on to the next thing. So like our objective is to make a machine, okay, to design a machine. And as a designer, what all things should we consider in it, right? So the broad objective of a design is to, like like the machine, whatever which we are going to make, should operate at its capacity during its service life, whatever it's given, right? And satisfying the basic requirement of the customer, right? As in the first lecture itself, we told you that a designer is a person whose job is to interact with the product and the people, and he only passes when he make the product safer and makes the customer happier, right? So the customer centricity should be our aim. Okay, cool, we'll move ahead. Nice. Okay, great. So what all things a machine element or machine should possess, right? The question is that. So let's answer it one by one. I have listed down quite a few, like the abilities or the some qualities which a machine element should possess. Okay. Well, for the time being, I'll just also pause and like tell you. Here I've written machine element, but it also means same as product element, or maybe for civil engineer also. Well, how a civil engineer can relate to this? Well, he has to make a building, let's say, and a building can be comprises of different floors. The floors comprises of different rooms. Okay, room comprises of different objects, etc., etc. So the building, the floor is a machine element, or let's say civil element for building. The rooms are the civil element for floors, and the objects are the civil elements for room. So all these things can be related. I guess like you all are capable enough for figuring that out. Nice. So what is actually strength? Why strength is required? So basically strength is required to avoid any failure, a fracture or general yield in the machine, right? A machine should be rigid. Why is that? Well, if it will deflect, then the like it might break, right? For example, a shaft is designed for lateral and torsional. Here I've written it also, lateral and torsional rigidity, right? A shaft is designed basis on that. If he possesses that, then the shaft like it's good to use. Next is wear resistance. Why wear resistance is required? Well, if a component is under continuous wear and tear, right? The geometrical dimensions of the objects might it might deteriorate over a period of time, right? As it deteriorates, the dimension changes. As the dimension changes, what happens is the accuracy of the tool changes. That's quite obvious, right? Let's say initially the tool was a bit of like a rectangle. Over a period of time, it got wear and tear, and like the shape got distorted, and like it's now like this, right? uh, only see the black portion, right? The tools like that. So obviously the accuracy won't be same, right? So wear resistance should be present. How we gonna do that? So generally gears are under more wear, right? So what we do is we do surface hardening. Well, we are going to discuss all those things in detail later on. I'm just giving you an overview so that you know like what are you driving yourself into, right? Now, minimum dimension and weight. Why this is required? Minimum dimension and weight is required so that you can make a product which has minimum material cost. As in design engineer, right? Any kind of design engineer, your aim should be to make a product with minimum cost. It could be initial cost, or it could be cost of operation. It could be anything like fixed cost, variable cost, it could be any cost, right? So our aim should be making it with minimum cost and minimum resources available, right? Now next is manufacturability. Obviously whatever design you're gonna make, it should be easy to manufacture. You know why? Because let's say you made a complex geometry, like let's say you just have to make a bottle, right? And this is just a basic design. Let's say design number one. The next design is like this. Okay. Let's say design number two, and there's third design also. It's like this. Okay. So and from this three designs, what design you might prefer? Well, I will prefer the design number two. You know why? Why is that? You know, third one lacks two things. First one is um the first thing is that it's difficult to manufacture. Okay, difficult to manufacture. Also the second thing is material cost will be more in this, right? The first one, it can be easy to manufacture, but the material involved is more, right? May like this constraint that all of three contain same volume. In that case, I will prefer this second number, water, right? Okay. Now coming back to the topic. So we discussed like manufacturability also. Safety is also very much a concern. The worst case scenario should be considered and fail-safe arrangement should be made. Well, I'll explain this with a very good and classic example, and it actually happened also in one of my careers. So, okay, there's a very like overhead tank. Okay, it's very much at the top of the building, right? And the people are standing here, right? And the tub level should be maintained to this one, okay? And there is actually a float arrangement. It was a very old thing, so a float was present, okay? And the float is attached to a limit switch, which actuates when the floats come up, okay? And when the tub level rises, it actuates and stops the flow of the inward flow in the tub, okay? What happened was the float got broke from this side. So well, in that case the limit switch will never be able to like get a command from the float. And what will happen, the tub level will always rise, and what will happen, overflow from the tub will happen, and maybe the people standing nearby might get hurt, right? Okay, so this was not a fail safe arrangement. So what we did was what the engineers at that time did was they this was the maintained level, and they added few more float walls, okay, and a level switch, and like ultrasonic this electronic device. So what happens was, uh, even if this float wall fails, okay, then also they have this three things working side by side. Let's say just two things, there's just one float wall extra and one electric ultrasonic this sensor, Okay, to like know the distance. Okay. Now, what happened was, even if this particular float breaks, then also there is a float. Let's say this float also breaks, then also this level switch, this ultrasonic switch will give the command that tub level is rising and it will stop the flow. So we are having two different mechanisms here. So what this is called, will the whole arrangement will be known as fail safe. Okay, and these two things which are present, this float valve and the limit switch, this are known as redundant mechanism. It means that even if one fails, then also another one is active. This make the whole arrangement very much safe and decreases the probability of making the tub overflow. Okay, so CFT is very one of the crucial parameter one should consider while designing. Next is conformance to standards. All the things like from industry to like maybe a college projects also. All the things have standards. Let's say you just have to make a building. Okay, now the standard says that the minimum height for a mezzanine structure should be 7.22 feet, right? So that thing should be there. Okay, this is as per the government compliance. It should be at least this much. If you're going beyond this, then it's okay. If you're going below this, then it's not possible. Okay, then you are going against the law. So standards are always present, and standards are made like for your own good. So maybe like you can get an access for that. Like on internet, you can get the access. Now, next thing in line is reliability. So, what actually is reliability? Well, it's nothing but just probability that machine will perform its function under the desired operating conditions for a lifetime. I guess that's very much true from the definition itself. Next is maintainability. Well, this is also a very important thing. An engineer should always think that if the system fails, okay, we often not think in that way, but we a designer must think that. So let's say if a system fails, then is it easy to maintain that or contain that or like solve the problem? Is it easy to do that? The question is that if it is easy, then the design is very much good. If not, then maybe like he should think for from in the perspective for a technician also. Okay. Now, minimum life cycle cost. As I told earlier, a designer should always think in terms of like cost optimization. So, cost paid by the purchaser, right? So after purchasing the equipment, if a purchaser is like paying the cost throughout its lifetime, then also the design is not very good, right? So a designer should look into that. Okay, so by that like overall like we have completed the basic requirements a machine element should possess, and we discussed with different examples and different meanings also. Okay, now next in line is the design methodologies. Now, design methods. So in this, we are going to discuss like the traditional method and the actual method what we use today and date. Okay, moving on. So designing methods. So first one is designed by craft evolution. I hope the before part is clear to you all. Okay, we started with what is machine, then we move on to the machine elements, and from there we opted like what are the basic requirements of the machine elements. We studied all those things. Machine element should possess the strength, reliability, wear resistance, okay, and this performance, safety, and all those things. If the machine element possesses that, then the overall machine is great. Okay, and what we are going to do is, well, if machine element possesses that, then the machine will already possess that. Okay, okay, so that thing is there. Okay, now let's moving on to the design methods. The first one is designed by craft evolution. I've taken example of two bullock carts. Okay, okay, so I can see that like there are two different bullock carts here. Okay, and the bull is like quite angry. I'll use a red color pen, okay, to make them more angry. Okay, great. So you can see the both the designs are different. Why? See the place where they keep the like the all the storage things. Let's say design one and this is design two. So for both of them it's different, right? So first difference is spotted. Second is this is a bit curved and this is a bit straight. So second difference. If you will move deep into it, you might find like there are so many differences, right? So in order to replicate this, it's not possible for me. You know why? Because no dimensional drawing is available. Also, if I will ask the person who made this, why have you given this a, like a curve, right? He might not have an answer for that. Or maybe if I will ask this person why have you given it a straight rod, he might not answer that, right? No justification is there. They just made it. Okay. So product develop, like this is developed from like the like from a trial and error methodology, right? So and let's say this particular curve is very much a good mechanism for this particular like bullock cart, right? But but if I will try to change it to a straight one, will that work it as good as this one? You never know. If you will try to do so, you like that's just an experiment. Okay, you don't know. Like maybe it might work, it might not work. You don't know, right? So the product development from trial and error, therefore it's make it difficult for modifying or change. The essential information like material, dimensions of the parts, manufacturing method are not very much available. As we can see, like both the bullock carts have the same kind of wheel, but maybe the manufacturing method for both of them are different, and they can change from place to place and time to time. You don't know, right? So this particular method is not very much optimum for overall, and it's obsoleted. You know why it's obsoleted? There's two things: the mass production is not possible, and also we cannot do sudden changes in design if there is any, right? So because of this too, this particular method become obsolete. Next is the method which we use till date. It is known as design by drawing. So what does a drawing means? A drawing is any component like anything which has a dimension in it. Okay, and also everything is like mentioned in it. Like okay, you can see anyone can replicate this, right? And the product is developed by trial and error process. Okay, sorry, sorry for that. I'm suffering from cold, and I just thought like to record this lecture, but it's okay. I think throughout it's okay. Oh, not problem. Great. So manufacturing can here we can subdivide the manufacturing. You know why? I have individual drawing of the component also. I have individual drawing of the assembly also, and like we can make it by different pieces also. We can give the task to different people also, right? So drawing makes it very much easier. And what we can do with the help of this, we can do mass production. Thus, we can overcome the first thing. Okay. Next is to develop product by trial and error method. In this, we already have a like drawing in software, so we can modify the changes and see like if it's possible or not. Let's say I want to increase the dia of the wheel, and let's say I want to do some changes with the mud guards and all, so I can do that. And if let's say while doing so, let's say the driver is hindering is leg in this, so that I can see in the software itself. I don't have to modify the whole vehicle for that, right? So those things are possible only in the second methodology. Thus like what happened with this, uh with the help of this, the industrial revolution also happened. Like the mass production can be done. Like any sudden changes as per the customer's requirement, it can be done so fine and like so good. Okay, uh, like it basically increases the customer experience, and as a designer one should focus on that. Okay, so I guess like overall, yeah, there you gotten hold of this lecture. This is a very basic lecture series, not series. This particular lecture, but I guess like a designer should have a knowledge for that. Like he should know his roots, where he came from. In order to make something very much new, he should know what basis he's from. Okay, I hope like I made it very much clear in this lecture. If you have any doubt, you can comment in the comment section. Okay, and also don't forget to like, share, comment, and subscribe to our YouTube channel, DesignVerse. Okay, I hope it's very much okay. And at the end of the lecture, I'll stick a screenshot from this, or maybe a photograph or PDF file with the notes in it. Okay, so you can copy it from that, or I'll suggest that you can just uh, go with this particular, you can just chalk this down. Okay, that is very much helpful, and you will do the revision also. Okay, so, and by the end of the whole series, this particular canvas, like it will be a mind map kind of thing. So you will know, okay, first we did that, then this, then this. So I call this approach as mind map. You all know Sherlock? Well, I am not Sherlock, but we can do that. Okay. So I hope it was very much clear, and uh, thank you. See you again next time.